Good day, viewers. This is Afeademola Johnson, your science tutor. We are continuing from our introduction to chemistry, and we are looking at the topic electron configuration. Configuration means arrangement. So electron configuration is the arrangement of electron in the atom of an element. The way electrons, so where are electrons found? Electrons are found in the following two parts of an atom. There are two parts of an atom where we have atomic shell and two, we have atomic orbitals. So we are going to consider atomic shell first. Atomic shell. Now, an atomic shell is a spherical orbit. A spherical orbit around the nucleus. Around the nucleus, where electrons revolve around the nucleus. So then let's look at, there are four types of atomic shell. These are, we have K shell, we have L shell, we have M shell, and lastly we have N shell. Now, looking at a table, in this table we are considering type of shell, we are considering maximum number of electrons held, and we have a formula to do that, 2n squared, to get the maximum number of electrons that shell can carry. The first shell we have is K shell. Now, value of n. So for K shell being number 1, the value of n is 1. So if I have 2 into 1 squared, it gives me 2 into 1 times 1, which is equal to as 2 into 1 times 1 is 1, which is equal to as what? 2. So K shell can carry maximum of 2 electrons. Then we have number 2 is L shell. In L shell, value of n is 2 because it's number 2. 2 into 2 squared gives me 2 into 2 times 2, which is 2 into 4, and that gives me 2 times 4, which is 8. So L shell can carry maximum of 8 electrons. Then number 3 is N shell. N shell, we have value of n is 3. We have 2 into 3 squared, which is equal to 2 into 3 times 3, which is equal to 2 into 9. 3 times 3 is 9. And this gives me 2 times 9, which is 18. So N shell can carry maximum of 18 electrons. Then we have M shell. Okay, LM. Okay, this is M shell, and this is N shell. So for N shell, value of n is 4. we have 2 into 4 square, which is same as 2 into 4 times 4. And that gives me 2 into 16, which is same as 2 times 16. And answer is 32 maximum number of electrons. Now, that is that. Then with this, we want to form the electron configuration. Of the first 30 elements. For the first 30 elements, so we have serial number, we have name of element, atomic symbol, then we have electron configuration. So in this electron configuration, we have K shell, we have L shell, we have M shell, and we have N shell. So we are dealing, number one is hydrogen. Now, when we want to fill this shell, this is like a car, and these are seats. Front seat is K shell. So this shell must be fully filled before you come and put electrons here. When this one is filled up, we put electron here. When this one is filled up, we put electron here. Hydrogen has only one electron, and that one electron is going to K shell. Go to K shell. The next one is helium. Helium is He, and it has 2 electrons. K shell can carry maximum of 2, so we drop the 2 here. Number 3 is lithium. Lithium has 3 electrons. And what do? The 3 cannot enter K, only 2 enter there. 2, then we have ratio. The remaining one is put under L shell. Then number 4 is beryllium. Beryllium Be has 4 electrons. 2 will go here and 2 will come here. So what you are seeing there is electron configuration. So let's look at more of them. Then number 5 is boron. Boron B. The configuration of boron has 5 electrons. So out of the 5, 2 will come to K shell, then the remaining 3 will come in to the L shell. Then number 6 is carbon. Carbon C, 2 to 4. The next one, nitrogen, N, 2 to 5. The next one, oxygen, oxygen O, 2 to 6. The next one is fluorine. Fluorine F, that's 2 to 7. Next one is neon. Neon Ne, that's 2 to 8. Next one is sodium. Sodium Na, 2 to this is 11 now. We put 2 here. We are left, when we remove 2 from 11, we are left with 9. But don't forget, N shell cannot take more than 8. So we put 8 there. The remaining one goes to M shell that can carry 18. It's only one that remains. Okay? The next one is magnesium. Magnesium Mg. So has 12 electrons. 2 stays here, 8 stays here, then we have 2 here. Then we have aluminium. Aluminium Al. 2 to 8 to 3. Then number 14, silicon. Silicon Si, 2 to 8 to 4. Then phosphorus. Phosphorus P, 2 to 8 to 5. Now, sulfur. Sulfur S, 2 to 8 to 6. Number 17, chlorine. Chlorine Cl, 2 to 8 to 7. Number 18, argon. Argon Ar, 2 to 8 to another 8. Number 19, potassium. Now look at potassium. For potassium and calcium, something special happened. Potassium and calcium. Now you have 19 electrons. 2 comes here. After 2, 8 comes here, making 10. So you're supposed to have 9. This 9 is supposed to stay at the next shell. Supposed to stay at the next shell, which is M shell can carry 18. So 9 is supposed to come here. But for potassium and calcium, now when we get to orbital, you understand something. That this shell, M shell for potassium and calcium, contains a 3p and 3d orbital. The p inside can take 6 electrons, while the d can take 10. Total, you have what? 6 plus 10, that's 18. That's how we come about this 18. But this 3d for potassium and calcium is bad. It doesn't carry electron. So it doesn't carry. It doesn't carry. No, you have a 3s, which carries 2 electrons, 3p, which carries 6 electrons, and 3d. So this one is bad. It doesn't carry electron. So we have a 2 plus 6 plus 10, making 18. So this one doesn't carry. If this one doesn't carry, then we are left with what? 2 plus 6, which is 8. So in that note, for potassium and calcium, M shell can carry 18, but it is considered to carry maximum of 8 because the 3D that will carry 10 inside the 18 does not carry electron. So we'll now put 8 here, and the remaining 1 will now be pushed to the other side. So that is what we have there. So now, let's move on. Let's move on. Now we are going to the next one now, which is 20. 20 is calcium. And calcium is Ca. The configuration will now be 2 to 8 to another 8 to 2. Then 21, scandium. Scandium is Sc. 21. But from scandium downward, the 3D is now will now start to carry electrons little by little. You have 2 to 8 making 10 to another now. This one will now be to 9 to 10. Don't forget this place can take 18. But the 3D now will manage to carry one more electron. This is to 2. Everything will be ending at 2 except copper and chromium. So we have 22 now. Titanium. Titanium Ti. 2 to 8 to 10 to 2. The increase is not going to be here. Then 23, we have vanadium. Vanadium V. 2 to 8 to 11 to 2. Then after vanadium, we have chromium. Chromium Cr. I will start. Chromium and copper have some exceptional different configuration. You have 2 to 8. This was supposed to be to 12 to 2. but it will now reduce this one to 1. Copper and chromium will end in 1, then that 1 removed from here will be added to this place, then we have 13 here. That's how they behave. Then after chromium, we have manganese, Mn, which will now be 2 to 8, is the one that will have the 13 and end in 2. Every other one ends in 2, 2. Then 26 we have iron Fe, which will be 2 to 8 to 14 to 2. Then 27 cobalt, that's 2 to 8 to 15 to 2. Then 28 we have nickel Ni, 2 to 8 to 16 to 2. Then 29 is copper, Cu, that is 2 to 8 Hem. It's supposed to be to 17 to 2. But what do? It reduces this one to 1 and add 1 to this one. So that's its nature. Then 30 zinc, Zn, 2 to 8 is the one that's supposed to be the 18. If this one has agreed to be 17, then ending in 2. So that is that. So we are going to consider some common terminologies associated with this electron configuration that we have had. Now, before that, let's try to draw the atom of sodium. Let's try to draw the atom of sodium. We start from the nucleus. Sodium has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 protons. That's atomic number. Then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So these are neutrons. How many neutrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 neutrons, 11 protons. The atomic mass is now adding them together. So this is nucleus. The nucleus of the atom. Then we have 3 rings here. 1, 2. Why we have 3 rings here? The electron configuration of sodium has 3 digits: K shell, L shell, M shell. So the first ring is representing K shell. The middle one is representing L shell, while the outermost one is representing M shell. Now, this outermost electron is called valence shell. Valence shell means the one that is the outermost. So, now, don't forget the configuration is of sodium is 2 to 8 to 1. That 2, these 2, we put it in K shell. 1, 2. Then we have these 2. This 8, sorry. The 8 now have 4, put 1, 2, 3, 4, then pair again. 5, 6, 7, 8. Then that's this 8. Then this 1 can be anywhere outside there. So this electron that is found outermost is called valence electron. Outermost electron is called valence electron. So, and these positively charged particles, they are the what? Proton. While these chargeless particles, they are the what? Neutrons. So what we have here is the diagram. sodium atom. Sodium atom, which is Na1123, with the configuration what? 2 to 8 to 1. 2 to 8 to 1. So that is what you have there. So let's look at common terms associated with electron configuration. So common terms found in electron configuration are, we have valence shell. 2, we have valence electron. 3, we have metals. 4, we have non-metals. And 5, we have noble gases. So, considering this, now let's talk about valence shell. What is valence shell? Valence shell means the outermost shell. The outermost shell of the atom of an element. For example, now M shell is the outermost shell, outermost or valence shell of sodium atom. For yourself, what about for neon? Kl, this L shell. For fluorine, 7. So, like that. Then we have valence electron. Valence electron. Now, valence electron is the electron found in the valence shell. So for example, this electron now, this one electron, for instance, sodium atom has one valence electron. Okay, then the next thing to look at are metals. What are metals? A metal is an element whose atom ionizes by loss of electron to form a positive ion. Now, so one thing to know is that the valence electron number of a metallic atom, the valence electron number of a metallic atom is either 1 or 2 or 3. So the valence electron is, let's look at an example. Examples are illustrated in the table below. So in this table now, we want to look at name of metals. Then electron configuration. First one is lithium. The configuration is what? 2 to 1. For ending in 1 is a metal. This one is not, is within either 1 or 2 or 3. Is low. You can easily lose it because it's too small. Then we have beryllium. Beryllium is lithium Ni. Beryllium Be. That's 2 to 2. So the valence electron is 2, so it's a metal. So if they ask you an element, can it add, is it a metal or a non-metal? Just try the configuration. If what you have outside is 1 or 2 or 3 is a metal, we have boron. Boron B. That's having 5 electrons, B5. So we have 2 to 3. Then number 4, we have sodium. Sodium Na11. So that is 2 to 8 to 1. So it's a metal. Then we have magnesium. Magnesium Mg12. That's 2 to 8 to 2. Then number 6 we have aluminium. Aluminium Al13. That's 2 to 8 to 3. It's a metal. Then we have potassium. Potassium K19. So this is 2 to 8 to another 8 to 1. Then you have calcium. Calcium Ca20. 2 to 8 to another 8 to 2. Then scandium to zinc. Scandium. This one is 2 to 8 to another 8, to 9 to 2. You can see what is ending with is what is 2. So it's a metal. So without wasting our time, you can see that here. You can see that here. Scandium ending in 2, titanium ending in 2, vanadium ending in 2, chromium ending in 1, manganese 2. All of them are ending in 2 and 1. So they are also metals. So that is that. Then we move on. Now, then the next one is non-metal. Non-metal. What is non-metal? A non-metal is an element whose atom ionizes by gaining electrons to fill up its outermost or valence shell and form negative ion. So examples, okay, how do you know a non-metals? The valence shell, the valence electron of a non-metallic atom is 4 and above. So examples of non-metals. Are given in the table below. So we have name of non-metals, atomic symbol, then electron configuration. So the first one we have helium. It's a noble gas. We have carbon C6. So that's 2 to 4. So when the valence electron is 4, 5, 6, 7, 8, it's a non-metal. Another one is nitrogen N7, 2 to 5. Next one is oxygen O8, 2 to 6. Next one is fluorine F and 9, 2 to 7. The next one is neon Ne8, that's 2 to 8. Next one is silicon Si14, that is 2 to 8 to 4. Next one is phosphorus P15, that's 2 to 8 to 5. All these are non-metals because their outermost electron is 4 or 5 or 6 or 7 or 8. Then number 8. Now we have sulfur S16. Configuration is 2 to 8 to 6. So number 9 is chlorine Cl17. That's 2 to 8 to 7. Then number 10, argon Ar18. That's 2 to 8 to another 8. So that's the end. These are the non-metals we have. Then the next one is noble gases or rare gases or inert gases. Or group O elements. Group O elements. These are elements whose atom have fully filled up valence or outermost shell with electrons. So their outermost shell is fully filled up with electrons. Look at helium. Okay? So then in that case, they do have a stable electron configuration. What does that mean? When something is stable, it's not shakeable. It does not lose electron. Stable electron as they do not lose or gain electron. So this means that they do not react. So this is why they are not chemically reactive. And because they are chemically reactive, that is why they are called inert gases. They are non-reactive property made them called inert gases. Inert gases. Now take note of one thing. Examples are, we have helium, He, 2, neon, Ne10. What is the configuration of this one? 2. What is the configuration of this one? 2 to 8. Then 3. We have argon. Argon Ar18, which is 2 to 8 to another 8. You can see, K shell can carry maximum of 2 and you have 2 here. L shell can carry maximum of 8 and you have 8 here. This one can carry 18, but I told you that the TDD does not carry electron, so it's considered to have also maximum number of what? Could carry maximum number of 8. And you have 8 there. So then take note of one thing. The type of stable electron configuration of helium is what? Is octet. Octet configuration. But for others, it is called, for helium is duplet. Duplet configuration. For others, it is called octet. Octet configuration. Don't forget, oct means 8, octagon. So all the rest now they have 8, ending in 8 and 8, but it's not what is ending in 2. So that is that. So I'm leaving you with a classwork. Now, state the number of paired and unpaired electron. Paired and unpaired electron in the atom of elements Q9. You are given something like this. Before I will now give you an assignment, what do you have to draw? You need to draw the shell diagram. Don't forget, first thing that will guide you is that 9 is 2 to 7. That one will guide you. Then just put the Q as the nucleus. This is your nucleus, then 2 digits. 1, 2. So you have 2 electrons here. 1, 2. This is 7. To put 7, before go 1 to each of the 4 corners. 1, 2, 3, 4, 5. Then start pairing. 6, 7. So from here, don't bother yourself about, you only consider the outermost electron, the valence shell. So number of unpaired electrons here is what? How many? This one is unpaired, it doesn't have a partner. It's 1. Then number of paired electrons is what? This one is what? How many pairs? This is paired, this is paired, this is paired. That is 3. So that is that. Take note of that. So we are going to stop here. I remain Ademola Johnson. See you in the next class when the next topic is going to be ion and radicals. I remain myself Ademola Johnson. Please, if what I have done to you is beneficial to you and it has a very long way of helping you in your life endeavor, can you please help me also to subscribe? Click the subscribe button, click the notification button in YouTube and share this video, and God will bless you and multiply you. Thank you, and if there's any question, don't hesitate to go to the comment section and ask. God bless you, and bye for now. Thank you.